Good day everyone, in this video I will show you how to solve transportation problem. But before that, let me explain to you first what is transportation problem. Transportation problem is a special type of linear programming problem where the objective is to minimize the cost of distributing a product from a number of sources to a number of destinations. For example, the jug company has 3 plants located throughout a state with production capacity of 55, 95, and 35 gallons. Each day, the firm must furnish its 4 retail shops, R1, R2, R3, and R4, with at least 20, 25, and 60 and 80 gallons respectively. The transportation costs in RS are given below. So we have 3 sources here, P1, P2, and P3. In P1, there are 55 supply available. P2, 95, and P3, there are 35 supply available. We also have destination, the retail, namely R1, R2, R3, and R4. For R1, we have 20 demand, R2, 25, R3, 60, and R4 with 80 units of demand. Here we will apply the 3 methods in solving transportation problem: the northwest corner method, least cost method, and the Vogel's approximation method. So ang gagawin natin is to get or calculate the total cost of delivery for the initial basic feasible solution of each method. Afterwards, we will pick kung alin ang least, then we will check or test its optimality using Moody method or UV method. At magkakaroon tayo ng looping until we reach the final optimum solution. So let's start! Here in our problem, we will check first if the total supply is equal to the total demand. So 55 plus 95 plus 35 is equal to 185. Also, 20 plus 25 plus 60 plus 80 is equal to 185. So it is balanced transportation problem. Otherwise, it is called unbalanced transportation problem. So magsisimula tayo dito sa northwest corner method. We will start filing the table from the upper left corner and gradually move to the lower right corner. So this is the northwest corner, and we will find out what is the demand and supply. The demand is 20 and the supply is 55. So the minimum of 20 and 55 is 20. So ito yung lesser value. So we have 20 units. So we have 20 units to the cell P1, R1. The demand for the first column is satisfied. And we will deduct the supply in the first row with 20 units. So the remaining supply is 35. Same procedure. So we will proceed to P1, R2. This cell, the demand is 25 and the supply is 35. So the lesser is 25. So we will allocate 25 here in P1, R2. And the second column, the demand is satisfied. And we will deduct 25 in the first row. So we have now 10 supply in the first row. Next in P1 and R3, this cell. The demand is 60 and the supply, the remaining supply is 10. So the minimum is 10. So we will allocate 10 here in P1, R3. So the first row is satisfied. And we will deduct 10 in the third column. So the remaining demand is 50. So there are 4 cells left. We will start this cell. This cell, the demand is 50 and the supply is 95. The minimum of 50 and 95 is 50. So we will allocate 50 here in P2 and R3. So this column is satisfied and we will deduct 50 here in the second row. So the remaining is 45. Next is this cell, P2R4. The demand is 80 and the supply is 45. The minimum is 45, so we will allocate 45 in P2R4. And we will deduct 45 in the fourth column. So the remaining demand is 35. and the second row is satisfied. Last, in this cell, the demand is 35 and the supply is also 35. So we will allocate 35 here in P3R4. So let us calculate the total cost of delivery for the initial solution. We have 6 times 20, 8 times 25, 12 times 10, 13 times 50, 4 times 45, 5 times 35. So calculate this one, we have the initial solution of 1,445. So we will now proceed to least cost method. According to this method, first we need to find out the least transportation cost or least value in all cells. So the least value is 4. We have in P2R1 and P2R4. So we will start here in P2R1. In this cell, the demand is 20 and the supply is 95. So the minimum is 20. So we will allocate 20 here in P2R1. So this column is satisfied. So it is cancelled. And we will deduct 20 in the supply in the row 2. So the remaining supply is 75. Next, the minimum transportation cost here is 4. So, in this cell, the demand is 80 and the supply is 75. So, the minimum is 75. So, we will allocate 75 here in P2R4. And this row, the supply is satisfied. And we will deduct 75 here in row 4. So the remaining demand is 5. Next, the least transportation cost is 5. So in this cell, the demand is 5 and the supply is 35. So the minimum is 5. So we will allocate here in P3R4. And this column is satisfied. And we will deduct 5 in the third row. So the remaining supply is 30. Next, we only have 4 transportation cost, 4 cells. And the least transportation cost, 8, 12, 16, 11 is 8. So this cell. This cell, the demand is 25 and the supply is 55. So the minimum is 25. So we will allocate 25 here in P1R2. And this column is satisfied and we will deduct 25 in first row. So the remaining supply is 30. Here we only have 2 cells. The minimum of transportation cost of 12 and 16 is 12. So this cell, the demand is 60 and the supply is 30. So the minimum is 30. So we will allocate 30 here in P1R3. And this row, the supply is met. And this is 0. And we will deduct 30 in this column. So the remaining demand is 30. Last is this cell. This cell, the demand is 30 and also the supply is 30. So we will allocate 30 here in P3R3. So that is least cost method. Now let's calculate the total cost of delivery for the initial solution. We have 8 times 25 plus 12 times 30 plus 4 times 20 plus 4 times 75 plus 16 times 30 plus 5 times 5. We have the initial solution of 1,445. Last is Vogel's approximation method. According to this method, before we solve the problem, first we need to find out the row difference and the column difference. For each and every row, and for each and every column. So, how can we identify the row and column difference? First, we need to select the least value and the second least value. So, in the first row, the least value is 6. And the second least value is 8. So, the difference of the two, 8 minus 6 is 2. So, that is the row difference. So, in the second row, the least value is 4. They are both 4. So, 4 minus 4 is 0. In the third row, 5 is the least value and 6 is the second least value. So, 6 minus 5 is 1. So, in column difference, the least value is 4 in the first column. The second is 6. So, 6 minus 4 is 2. In the second column, 10 minus 8 is 2. The third column, 13 minus 12 is 1. In the fourth column, 5 minus 4 is 1. After that, we need to find out the maximum of both column difference and row difference. So the maximum is 2 in row 1, in column 1, and column 2. So we will select in column 1. After that, in column 1, we need to find out the minimum of transportation cost in column 1. So the minimum transportation cost, 646, is 4. So we need to select this cell. So in this cell, P2R1, the demand is 20 and the supply is 95. So the minimum is 20. So we will allocate 20 in P2R1. So this column is satisfied. And we will deduct 20 in the second row. So the remaining supply is 75. So same procedure in the remaining cells. And we will not include this column since the demand is met. So same lang yung ating gagawin. So the least value in the first row is 8. And the second least value is 11. So 11 minus 8 is 3. 10 minus 4 is 6. 11 minus 5 is 6. In the first column, so the demand is met. The second column, 10 minus 8 is 2. 13 minus 12 is 1. And 5 minus 4 is 1. So the maximum in both column difference and row difference is 6. So we will select in the second row. In the second row, the transportation cost is 10, 13, and 4. And the least value is 4. So we will select this cell. In this cell, the demand is 80. And the supply, the remaining supply is 75. So we will allocate 75 here in this cell, P2R4. So in this row, the supply is met. So it is cancelled. And we will deduct 75 here in the fourth column. So the remaining demand is 5. Same procedure pa rin. So the maximum, both column difference and row difference is 6. So we will select the row 3. In row 3, the transportation cost is 5, 16, and 11. So the least value is 5. So we will select this cell. In this cell, the demand is 5, the remaining demand. And the supply is 35. So the minimum is 5. So we will allocate 5 here in P3R4. And this column is satisfied. And we will deduct 5 here in row 3. So the remaining supply is 30. So same procedure pa rin. In first row, 12 minus 8 is 4. And in third row, 16 minus 11 is 5. In second column, 11 minus 8 is 3. 16 minus 12 is 4. And the maximum in both column difference and row difference is 5. Here in third row. Here in third row, the remaining cell transportation cost is 11 and 16. So the least value is 11, so we will select this cell. In this cell, the demand is 25 and the remaining supply is 30. So the minimum is 25. So we will allocate 25 here in P3R2. And this column is satisfied. And we will deduct 25 here in third row. So the remaining supply is 5. We only have 2 cells. So in first row, the row difference is only 12. And in third row, 16. And in third column, we have 16 minus 12 is 4. So the maximum in both column difference and row difference is 16. So we will select the third row. In third row, we only have one cell, 16. So we will select this cell, P3R3. The demand is 60 and the remaining supply is 5. So we will allocate 5 here in P3R3. And this row is satisfied. And we will deduct 60, so the remaining demand is 55. Last, we will select this cell. This is the only cell left. So the demand is 55 and the supply is also 55. So we will allocate 55 here in P1R3. Now let's calculate the total cost of delivery for the initial solution in Vogel's approximation method. $660 plus 80 plus 300 plus 275 plus 80 plus 25 is 1,420. Now we will test its optimality using Moody method or also known as UV method. So, gamitin natin kung ano ang nakuha natin sa Vogel's approximation method. And we will just add column and row for UI and VG. We have U1, U2, U3, V1, V2, V3, and V4. So here we have 6 allocated cells or occupied cells. So our first step is to find UI and VG for all occupied cells, where Cij is equal to UI plus VG. So this is our formula. To do this, we need to let U3 is equal to 0. So U3 is equal to 0. If U3 is equal to 0, we can find V2. We can also find V3 and we can also find V4 using this formula. So we can also rewrite this formula in finding our UI and VG. So if we have U3 is equal to 0, we can find V2. So V2, our Cij is 11 and our U3 is equal to 0. So 11 minus 0 is equal to 11. So V3, our Cij in allocated cells, 16. Minus, our UI is 0. So 16 minus 0 is 16. And we can also find V4. In V4, in allocated cells, we have Cij is 5 minus our UI is 0. So 5 minus 0 is 5. So looking at the allocated cells, we can also find our U1. Our U1 is equal to, we have Cij and we also have VG. Our Cij is 12 minus our VG is 16. So our U1 is negative 4. We can also find our U2 since we have Cij and we have also VG. Our Cij is 4 and our VG is 5. So our U2 is negative 1. Lastly, we can find our V1. The Cij is 4 and the UI is negative 1. So 4 minus negative 1 is equal to 5. Our V1 is 5. Our second step, we need to find Dij for all unoccupied cells, where Dij is equal to Cij minus Ui plus Vj. So that is our formula in evaluating the unoccupied cells. So first, in this cell, this is unoccupied cell, P1R1. P1R1, also called as D11, is equal to our Cij is 6 minus our Ui is negative 4 plus our Vj is 5. So 6 minus negative 4 plus 5 is 1. So 6 minus 1 is equal to 5. Next unoccupied cells is this cell, P1R2. P1R2, also known as D12, is equal to 8 our Cij minus the Ui is negative 4 plus the Vj is 11. So 8 minus negative 4 plus 11 is 7. So 8 minus 7 is 1. Next unoccupied cells here in P1R4. Known as D14, is equal to the Cij is 11 minus our Ui is negative 4 and the Vj is 5. So 11 minus negative 4 plus 5 is 1. 11 minus 1 is 10. Next unoccupied cells here in P2R2. Also known as D22, is equal to the Cij is 10 minus the Ui is negative 1 plus the V2 is 11. So 10 minus negative 1 plus 11 is 10. So our D22 is 0. Next unoccupied cells here in P2R3. Known as D23, is equal to the Cij is 13 minus our Ui is negative 1 plus our Vj is 16. So 13 minus negative 1 plus 16 is equal to 15, is equal to 13 minus 15 is equal to negative 2. Last unoccupied cells here in P3R1. D31. The Cij is 6 and the Ui is 0 plus the Vj is 5. So 6 minus 0 plus 5 is equal to 5. 6 minus 5 is 1. Looking at the result, we need to note that if the value of our Dij is greater than or equal to 0, it means that the optimality is reached. And since there is negative value here found in P2R3, therefore it is possible to reduce the total cost of delivery. So our step 3 is choose the minimum negative value for all Dij. So there is only one negative value here found in D23. And going back to the table, we need to locate the D23 here in this cell. So we need to mark this cell. Now focus on allocated cells. We will draw close path from P2R3 to P3R3. to P3R4 to P2R4. After that, from the origin, we will put plus minus sign allocation. So this one is plus, minus, plus, and minus. As we can see, we choose these cells, these allocated cells. Because if we will increase this one, we can decrease this one. And we can increase this one, and we will decrease this one. And we cannot choose these allocated cells. Since there are no allocated cells near to it, we cannot make adjustments. So if we can make adjustment this part, the supply and the demand remains satisfied. Now focus on the negative sign. The minimum of 5 and 75 is 5. So we will use 5 for adjustment. So we will add 5 here since it is positive sign. So we'll add 5. It is minus sign, so we will minus 5 here in this cell. We will add 5 here in this cell, and we will minus 5 here in this cell. So compute, we have another allocated cells here in P2R3. So there are no allocated cells here in P3R3. So since 5 minus 5 is 0. Here, 5 plus 5 is equal to 10. And 75 minus 5 is equal to 70. So we have new solution here. After that, we will go back to step 1 to step 2. And we will add column for UI and row for VJ. Now, follow pa rin tayo sa formula in step 1. And we will let U2 is equal to 0. So if we will let U2 is equal to 0, we can find V1, we can also find V3, and we can also find V4. So we will start V1. V1, the Cij is equal to 4. We need to focus on allocated cells or use cells. 4 minus our UI is 0. So 4 minus 0 is equal to 4. In V3, the Cij is 13. And the UI is 0. So 13 minus 0 is equal to 13. Next is V4. V4, the Cij is equal to 4. Minus UI is 0. So 4. Focus on allocated cells. We can also find our U1. Since we have Cij and we have Vj. Our Cij is 12. And our Vj is 13. So U1 is 12 minus 13 is equal to negative 1. We can also find our U3 using these allocated cells. Our U3 Cij is 5 minus our Vj is 4 is equal to 1. Our U3 is equal to 1. And we can also find our V2 using these allocated cells. In V2, the Cij is 11 and our UI is 1. 11 minus 1 is equal to 10. So that is our step 1. So we'll now proceed to step 2. In step 2, we still need to use the formula, which is Dij is equal to Cij minus the quantity of UI plus Vj. And we will find Dij for all unoccupied cells. So we will start here in unoccupied cells P1 and R1, so known as D11. The Cij is 6 minus the UI is negative 1 plus Vj is 4. So 6 minus negative 1 plus 4, we have 3. So 6 minus 3 is equal to 3. So same procedure for all unoccupied cells using this formula. So after computing all unoccupied cells, we have D11 is equal to 3, D12 is equal to negative 1, D14 is equal to 8, D22 is equal to 0, D31 is equal to 1, D33 is equal to 2. And we notice that there is still negative value found in D12, which is negative 1. So we still need to proceed in step 3. In step 3, we need to go back to the table and we need to locate the negative 1, which is D12. So negative 1 is here in D12. Negative 1. And we need to make adjustments. So if we will increase this one, we need to focus on allocated cells. So these are allocated cells. So if we will increase this one, we can decrease this one. And we can also increase this one, these allocated cells. And we can decrease this allocated cell. And we can increase this allocated cell. And we can also decrease this allocated cell. Or we can also draw a line in the allocated cells. This is the sign for our adjustment. So focus on the negative and we need to find out its minimum value. The minimum of 55. And we also have 70. And we also have 25. So the minimum is 25. So we will use 25 in our adjustment. We will subtract 25 from all negative. And we will add it to all positive. So we will add 25 here. So this is our new allocated cell. So compute 55 minus 25 is equal to 30. 5 plus 25 is equal to 30. 70 minus 25 is equal to 45. Then 10 plus 25 is equal to 35. So we have new solution here and we need to go back to step 1 to step 2. So we add column here for UI and we add row here for our VJ. So we need to let U2 is equal to 0. If we let U2 is equal to 0, we can find our V1, our V3, and V4. So we will start first in our V1. Our Cij is 4. And our UI is 0. So 4 minus 0 is equal to 4. So same procedure pa rin kanina. And we need to focus on allocated cells. Now we have the value for our V3, which is 13. V4 is 4. U1 is negative 1. And U3 is 1. And V2 is equal to 9. Next in step 2, using the formula Dij is equal to Cij minus Ui plus Vj. And we need to find out the Dij for all unoccupied cells. So we'll start here in D11. In D11, the Cij is 6. And the UI is negative 1. Plus Vj is 4. So 6 minus negative 1 plus 4 is equal to 3. So 6 minus 3 is equal to 3. Next is D14. The Cij is 11. Minus our UI is negative 1 plus our Vj is 4. So 11 minus negative 1 plus 4 is equal to 3. So 11 minus 3 is equal to 8. Next is D22. Our Cij is 10. Minus our UI is 0 and our Vj is 9. So 10 minus 9 is equal to 1. Next is D31. D31, the Cij is 6. Minus our UI is 1 plus 4. So 6 minus 5 is equal to 1. Next is D31. D32 rather. D32. D32. The Cij is 11. Minus the UI is 1 plus our Vj is 9 is equal to 11 minus 1 plus 9 is equal to 10. So 11 minus 10 is equal to 1. Last is D33. In D33, the Cij is 16 minus our UI is 1 plus our Vj is 13. So 16 1 plus 13 is equal to 14. So 16 minus 14 is equal to 2. So as we can see, there are no negative value in our Dij. So final optimal solution is arrived. So this is our final optimal solution. We have x11 is equal to 0. And our x12 is equal to 25. x13 is equal to 30. x14 is equal to 0. x21 is equal to 20. x22 is equal to 0. x23 is equal to 30. x24 is equal to 45. x31 is equal to 0. x32 is equal to 0. x33 is equal to 0. And x34 is equal to 35. So this is our feasible solution. Here the minimum shipping cost is 8 times 25 plus 12 times 30 plus 4 times 20 plus 13 times 30 plus 4 times 45 plus 5 times 35. 200 plus 360 plus 80 plus 390 plus 180 plus 175 is equal to 1,385. Therefore, Jug Company has a minimum transportation cost of 1,385. And that's all for this video all about transportation problem. Thank you for watching.